So there are some new reactions you learn in Chem 30 that are different from your typical formation, decomp, and so on. And these are specifically organic reactions. So looking at our first slide, this is just telling us the different types of organic reactions you need to know in Chemistry 30. So the first one that we'll look at is esterification, then combustion, which is relatively the same as what you've done before. Then there's addition, elimination, and substitution. So the first one, esterification, this is how esters are formed. So it's always a carboxylic acid, and it doesn't really matter what the long chain is. It's just that the OH group is going to come together with a H from an alcohol. So you need a carboxylic acid present and an alcohol. And when that happens, that will come and form water. And then the rest of it will link together. And that's what's happening from the to form that ester. So the ester has the part from the alcohol and the part from the carboxylic acid. This information above the arrow is just implying that there is a catalyst present, and this time it's going to be an acid. When we're taking a look, here's a few examples. So the first one's done for us. Propanoic acid with penta-1-ol to make pentyl propanate plus water. So let's go ahead and draw out the next one. So if you have propan-1-ol, so that would be having propane, 3 carbons with an OH group on the end, filling in the rest with hydrogens. So just drawing out that alcohol. You're going to add on ethanoic acid. So ethanoic acid, I'm going to put my carbon on with the double bond oxygen on this side, just so it's a little bit easier to see what's happening. And then ethane means 2 carbons, and this other carbon would have all of your hydrogens. So when we have that carboxylic acid close to the alcohol, an OH will come together with an H, and it will form water. And then the rest will link together. So you're going to have that carboxylic acid part, so that C double bond O single bond to another carbon with all of those hydrogens. And then that rest, or that last bond, when you had that oxygen, that is still there, but now oxygen needs something to bond to over here because it lost its hydrogen. And this carbon needs something to bond to because it's lost its OH group on the end. So that chain is going to come in and attach itself to the oxygen. And that is how we're forming the ester. So now we have the ester from the alcohol that you'll name first. You have a propyl group. And then from the rest, you have ethanoate. And you also have that water as a product, and that it shows us it also falls under not just esterification, but all of these will be condensation reactions as well. Okay. So there is one more example, but I think we'll just do this as a line diagram to save a little bit of time. So butanoic acid, butane means 4, so 1, 2, 3, 4. If it's oic acid, that means you have a double bond to an oxygen, single bonded to an OH group, adding an ethanol. So the ethanol, it would be a 2-carbon chain, and that's what that would show. 1 carbon here, 1 carbon here, and this is attached to a OH group. So from here, the OH and H will leave and form water, making it partly a condensation reaction as well, and the rest will join together. So we still have that first part here with the O, and now the OH is left, but we have this O over here that is connected to a carbon right here, which is connected to another carbon. So we have that water and the ester. So that is esterification, when a carboxylic acid and an alcohol get close enough to each other together to form water, they'll leave and the rest join. So with that, here's an old diploma question where you have a carboxylic acid and an alcohol, and you're forming an ester and water. So the type of reaction, this would be esterification. Name of compound 1. So compound 1 is right here. That is a carboxylic acid. There's 2 carbons in the main chain, so it'd be ethanoic acid, so number 2. Name of compound 2. Compound 2 is looking at our ester, the product. You always name the part of the alcohol first. So this would be ethyl ethanoate, so number 3. And classification of compound 2, well, that is definitely an ester. Okay. Our next one for combustion, it's nothing new here. The biggest thing is we need that molecular formula, and then you would have done what you would have before. Combustion reactions is always your hydrocarbon in the presence of oxygen, and your products will always be carbon dioxide and water. So with this one, when we are going to write it out, we do want to figure out what this is. If it helps you to draw it, and that helps me, so then I would draw it first so that you can get the molecular formula. So for this one, pentane, 1, 2, 3, 4, 5 carbons. Sorry about that. 5 carbons on, and again, on carbon 2, you have a methyl group. On carbon 3, so maybe we'll just draw the whole thing in here. So we have 2 on carbon 2. On carbon 3, nothing. On carbon 4, another methyl group. And then you need to fill in all of your hydrogens. Okay, so I drew that out, so now I can count what I have, just because I find it's harder to look at the name and know how many hydrogens, but some people can do it. So if you can, great, just go ahead and skip this step. But if not, I want to see that I have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So C8, H, and I need how many H's I have. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Hope I did that right. So 18 hydrogens. Just want to count that one more time. 7, 8, 9, 12, 13, 14, 15, 16, 17, 18. All right, so then we have that in the presence of oxygen, and your products always carbon dioxide and water. Now we can bring this one more step because we want to balance it. So to balance this out, we will start with hydrogens. There's 9 of them. Carbons, there's 8 of them. Then with the moving on to oxygen, so we will have to balance this out. But on the product side, it's coming from 2 places. So we'll have 16 from the carbon dioxide and 9 from the water. So that would be a total of 25, and that needs to be shared by 2 atoms. So we'll put a 12.5 here, or you can keep a fraction, or you can multiply everything by 2 and get rid of the decimal and the fraction. So this is also asking for the structural balance equation, and that would just be showing this now with oxygen making carbon dioxide and water. But really, if you can do this, this is what we're looking for when it is a combustion reaction. Our next one is an addition reaction. Addition reactions happen when you are breaking a double bond. So the only type, so breaking a double bond, I should say, or a triple bond. So this cannot have a molecule with just single bonds. We must see a double or triple because that bond gets broken. So if you have limited chlorine and you're reacting it with ethine, so ethine means there are 3 bonds between the carbons, and then we have hydrogen still, so that we have that last bond. And now we're reacting this with chlorine. I'm going to write it like this because we know chlorine is diatomic, so there would be 2 of them, so 2 chlorines together. If it's limited, that means we're just going to break one of these bonds. And if you break a bond, that means each of these carbons can now bond to one other thing. And if it's limited, that means this chlorine will come and bond to each of these carbons. So here, our molecule is now carbon, double bonded carbon with a chlorine and a hydrogen on each carbon. With this next part, the difference saying excess, that means all the bonds are breaking. So we're not just going to break one, we're going to break all of them. So if you have carbon triple bonded, right, and you break the first one, it can bond to something else. You break another, it can bond to something else. If you have excess chlorine, that means we don't just have 2 chlorines we're adding in, we have enough to make this reaction happen. So if that's the case, then we no longer have any double or triple bonds, and the hydrogens were still there, but we added on chlorine to the molecule. Our next one is elimination, and elimination forms a double bond. So I like to redraw this molecule in particular. And if I were to do that just in a way to show everything that's present, I would have hydrogens on that first carbon, an OH group on that second carbon, and hydrogens on the last. Now, whenever OH and H are close enough together, they like to leave the molecule as water. And if that happens, each of these carbons now are not happy because these bonds wouldn't be there. And each of these carbons are only bonded to 3 out of their atoms, but they want to be bonded to 4 other atoms. So to make them happy, they'll bond with each other. So this becomes C, single bond carbon, double bond carbon. And then we can draw in all of those hydrogens. And then just noting once more that water was formed. Our last one is substitution, and a substitution reaction is just essentially something is subbing in and something else is subbing out. So if we have ethanol and it's a substitution reaction, let's start by drawing this. So ethanol, doesn't matter which carbon you put your OH group on, it just has to be on a carbon, plus HCl. If it's a substitution reaction, we are going to swap. So here, I think a few ways to think about it. If we're actually swapping, I'm just going to swap the OH group with chlorine. The other way you could always think too is that the OH is coming together with that hydrogen to form water. So water is definitely a product, but the rest that we have is still our ethane, but now we have a chlorine on that carbon that lost its OH group. And there's other reactions you might be, or different products or different ways you can probably see that one. But it's up to you if we get there and how you react it. But we needed a substitution. So this decided to close, and that's okay. The last little bit was just that quick summary. So combustion, do what you were used to. Addition means you're forming that double bond. Addition means you're breaking. Elimination, you're forming. Substitution, you're swapping. And esterification, you are a carboxylic acid coming close to an alcohol and you are forming that ester and water. Thank you for watching. If you did find this helpful, please like and subscribe. And as always, if there's something you would like me to do, please just leave me a comment. Thanks for watching.